All right, we're going to do a few ellipse application problems together before you try some on your own from the textbook. So an arch of a bridge over a highway is semi-elliptical in shape, and it is 60 feet across. The highest point of the arch is 20 feet above the highway. Add the above information to the diagram below. Let the center be at the origin. All right, so the highest point is at 20 feet. The whole bridge is spanning 60 feet. So I'm just going to label this because I want to know A. A must be 30. And they said this can be the center, and we're going to put that at 0, 0. Write an equation for the ellipse. 0, 0. So I know I can start out by writing x squared plus y squared equals 1 for this ellipse. So my A value is bigger in the x direction, and 30 times 30 would be 900, and my B value is 20. 20 times 20 is 400. So now I have an equation to model any point that I want on this bridge above the highway. Or it's a, bridge. So use your equation from part B to determine the height of the ellipse 20 feet away from the center stripe. Here's the center. Here would be about 20 feet away. They want to know where that point is. They want to know this height right here. They want to know y. And they're telling you that x is 20. So if you know one of the points for an equation, you can plug that in to find the other point. So I'm going to plug 20 in for x. 20 squared divided by 900 plus y squared divided by 400 has to equal 1. 20 squared divided by 900 is just a number, right? So this number is 4/9, right? Then I could do 20 squared divided by 900 if I wanted to. Math fraction, that's 4/9. So I'm actually going to take 4/9 and subtract it to the other side. What is 1 minus 4/9? Isn't that 5/9? I'm just doing this so that I can kind of do it with mental math here. Y squared over 400 equals 5/9. And you could just do it with decimals if you want. So what would be your next step to solving for y? You would have to multiply both sides of the equation by 400 to get y squared by itself. So 5 times 400 is 2,000. So I have, I'm just going to bring it down here, y squared equals 2,000 over 9, which is a decimal. My last step, I want to take the square root of both sides of the equation. So what is the square root of 2,000 divided by 9? I got 14.9. So that is the height of the bridge. When I'm 20 feet away from the center stripe, the bridge is 14.9 feet tall. 14.9 feet. Part D, a truck that is 12 feet 6 inches tall this time wishes to pass through the tunnel. If one side of the truck is laying on the center stripe, what's the maximum width of the truck? So you're going to resolve this equation up here, but now we're looking for x, because x is the width. They're telling you the height is 12.5 feet tall. I made it a decimal to make it easier, right? 12 foot 6 inches is 12.5 feet. I'd like you to solve this equation the same way we just solved example C. So pause the video first and then make sure that you got the right answer. So now I'm going to go through the answer, so you should have already gotten the answer. This is 12.5 squared over 400. So I'm going to take 1. I'm going to subtract 12.5 squared over 400. So I get x squared over 900 equals this decimal. Multiply by 900 on both sides, and then take the square root of what you got. So the truck could be 23.4 feet wide and still fit under the bridge. Let's see. Have you ever heard of whispering galleries? I think it was mentioned in the video you watched, the YouTube video about interesting applications of ellipses. So a hall with a semi-elliptical ceiling, which just means half of an ellipse, is designated to be a whispering gallery. The length of the room is 100 feet. All right, so length of the room is 100 feet. If the foci are located 25 feet from the center, that tells me that C is 25. How high is the ceiling? So we're going to solve for this B value, and then they want us to add, assume the vertical walls supporting the domed structure are 8 feet. So we've got 8 feet that we need to add on at the end. Here's my semi-ellipse up in the dome. And I can record A. If the whole length of the room is 100, A must be 50. I'm really solving for B, right? So I'm going to use my A squared equals B squared plus C squared equation. 50 squared equals B squared plus C squared. So solve for B and then add 8. So you should try to do that on your own. So I got that B was 43.3 and then I need to add 8. So the total ceiling height, 51.3 feet. I just said in parentheses 8. B by itself is 43.3. All right, here's a challenging example of an ellipse application, kind of this idea of planetary orbits. In this case, we're looking at the moon traveling around the Earth in an elliptical orbit, and the Earth is at one focus. So that's important. The Earth is actually at the focus of the orbit. So if I was going to draw in my center is here and the focus is here. And I kind of have that down here. So it says the major and minor axis of the orbit have these lengths. That's the whole major axis, right? So that's 2A, and the whole minor axis. So that's 2B. Find the value of A and B. So I'm just going to divide those lengths by 2. So A is 384,403 and B is 383,873. Find the value of C. Pause the video, do the Pythagorean identity, and come back and show me what you got. And now I'm going to do the answer. 384,403 squared equals 383,873 squared plus C squared. So I'm going to take this, square it, subtract this, and take the square root. I got that C is about 20,178.9. All right, here's an idea that maybe you know about and maybe you don't, but have you ever heard of the moon called a supermoon? So a supermoon is when the moon is a full moon for us on Earth and it's at the closest point in its orbit. So the moon actually does change its distance away from Earth slightly. And so the apogee is when the moon is the furthest away. So here's the moon, right? And the Earth in this picture is at the opposite focus, but that's okay. So here's the Earth, it's at a focus. So when the moon is over here, it's got this plus this, how far away it is. The Earth stays put. When the moon goes around, when the moon is on this part of the orbit, it's only this far away, perigee. So we're going to use our A, B, and C values to figure out what is apogee and perigee for the moon. If this is a focus, then this right here must be C. And we already know that this distance must be A. So to find the apogee, we can just add A plus C. Well, how are we going to find perigee? Well, this distance is also A. So to find perigee, we're actually going to take A and subtract off C. So my apogee and my perigee. So we said apogee is the furthest away. We're going to add A plus C. 384,403 plus 20,178.9. 4045, I'm just going to round 82. Perigee is, I'm going to take A, 384,403, and subtract 2178.9. A minus C comes out to 364,224. This is in kilometers. The moon is still really far away. Just for interest's sake, what is the eccentricity of this orbit? So if I take 20,178.9, divide by 384,403, so the eccentricity of this orbit is 0.05. It's that circular of an orbit. So it's really circular. You're not going to notice much difference in where the moon is located. The last application, and then you can try some on your own from the textbook. The band wants to form a perfect ellipse on the football field at the next game. They will use a rope with two people holding the ends at the foci to determine their position to make this ellipse. A football field is 300 feet long and 160 feet wide. I hope that's accurate. The band wants to make as large of an ellipse as possible. It looks like they're not going into the end zones. How long should the rope be, and where should the two foci be? So remember this picture. So here's my ellipse. Here's a focus. Here's a focus. So people are going to be standing there. And then like this person is going to hold a string tight and they're going to stand right there. And then the next person, they're going to hold the string tight. The string's not going to change length, right? It's going to go all the way around. How long does the string have to be? I showed you this when we first started talking about ellipses. How do I get this point over here? So if this is a focus and this is a focus, I'm going to stretch my string. I'm just going to kind of show two parts of the string. So I've got this little part of the string from here to here and this big part of the string from here to here. Can I take this little part of the string, focus to vertex, and insert it over here, focus to vertex? Now don't I have one string that is equal in length to the major axis? And the major axis is 2A, right? So in this case, our length of the major axis is 300 feet, which tells us that A has to be 150. Where should the two foci be? I'm looking for the C value in this part then. So I know that A is 150 and B has to be 80, right? Because the B value is half of the whole field. So you're going to do A squared equals B squared plus C squared and find C. So pause the video and try it yourself. And now I'm going to do it. 150 squared minus 80 squared. Take the square root. It looks like the foci are 126.9 feet from the center of the field on the major axis. If you were going to tell them where to stand, this is supposed to say major, M-A-J-O-R. All right, there was some work together on application problems.